We're going to explore something called the sampling distribution in this video. So to help us understand what a sampling distribution of the mean is, we're going to do an example. So let's notice in this example, we want to find the sampling distribution of the mean with samples of size 2 for a very small population that has only 5 pieces of data in it. Now, of course, most of the time we're not going to have a population so small, but we'll see that we really need a small population to do this example. All right, so let's list all samples of size 2 that we could take from this population of 5 objects, whatever they might be. So let's notice, if we just sort of do this in a systematic manner, a sample of size 2, I could have the 25 together with the 24. That's a sample of size 2. I could have the 25 together with the 22. I could have the 25 together with the 29. I could have the 25 together with the 26. All right, now that's everything that has the 25 in it. So just continuing in a systematic fashion, I could have the 24 together with the 22. I could have the 24 together with the 29. I could have the 24 together with the 26. That takes care of the 24 and the 25. So let's move on to, we could have the 22 together with the 29. And I could have the 22 together with the 26. And then lastly, I could have the 29 together with the 26. And that's all of the samples of size 2 that we could make from these 5 individuals in the population. All right, so now that we've got our individual samples, we're going to go through and we're going to find the mean for each of the samples. So in other words, for the 25 and 24, I'm going to add them together, 25 plus 24, and then divide it by 2. And when I put that into the calculator, I'll get 24.5. I'll do the same thing for 25 plus 22. That'll give me 47, and I'll divide that by 2, which will give us 23.5. And then again, the same thing for 25 and 29. Add them together and divide by 2, and we will get 27. And then the same thing for 25 and 26. Add them together, divide by 2, we'll get 25.5. The same thing for 24 and 22. Add them together, divide by 2, we'll get 23. For 24 and 29, add them together and divide by 2, and we'll get 26.5. And 24 and 26, add them together and divide by 2, we'll get 25. And 22 and 29, add them together and divide by 2, and we'll get 25.5. And then let's see. 22 plus 26, and then divide by 2, and we'll get 24. And then finally add our 29 and our 26 together and divide by 2, we will get 27.5. Now, provided I've made no silly errors here, we should have the correct things in here. And now we're going to go over here and we are going to determine what the probability of getting each of those is. Now, assuming that all of these samples are equally likely that we can have the same likelihood of getting 25 together with 24 and 25 together with 22, then we can go ahead and do our probability over here. So let's notice 24.5. If we look among these, it's the only one, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different means. So the probability is 1 out of 10. 23.5, again, doesn't occur a second time. So it's 1 out of 10. 27 only occurs once, so it's 1 out of 10. 25.5, however, occurs twice, so its probability is 2 out of 10. 23 occurs once, so its probability is 1 out of 10. 26.5 occurs once, so 1 out of 10. 25 occurs once, so 1 out of 10. Now 25.5, we've already listed its probability, so I'm just going to leave that one with a little blank in it, showing it was up here. 24 only occurred once, and 27.5 only occurs once. All right, and notice if we add all these up, 1 plus 1 plus 1 plus 2, and then all of these ones, it'll add up to 10 over 10, or 1, and our probability should always add up to 1. Now, this is the sampling distribution of the mean, but let's notice some important features of this sampling distribution. First of all, since my population is so small up here, we could easily find the mean of our population. The mean of our population, if we add up all 5 numbers, and then divide, of course, by 5, we will get 25.2. All right, now let's do something different, though. That was the mean of a population. We're used to that. I'm going to take the mean of the sample means. Okay, so up here, for each of these samples, we found a mean over here to the right in the second column. I'm going to now take all 10 of these means, and I'm going to average them together. I'm going to find their mean. So if I average together all of these, all 10 of them, and of course we're going to divide by 10 since there are 10 of them, I get again 25.2. All right, so this leads us to an interesting conclusion. The mean of the population is equal to the mean of the sample means. All right, so that's kind of interesting. Now we'll see how that helps us in a minute. Now, I could, and I'm not going to go through that tedious process here, but I could take this original 5 things in this population, put them into Excel, and find their standard deviation. I could then take these means right here and find their standard deviation. And here's what I would find. I would find that the standard deviation of the population is equal to the standard deviation of the sample means divided by the square root of the sample size. Okay, so let's summarize this and also put it into symbols that you might see in your homework. So here are our symbols for what I just said. Remember, mu is our symbol for the population mean, the population average. Well, we have a new symbol for the average of all of these sample means. And remember, X bar is our symbol for sample means. So this is the mean of all of these means. All right. It's what I did when I added up all of those means and divided by the same number of means that I had. It turns out that the population mean and the mean of the sampling distribution are the same. So that's nice. We can just use this every time we need the mean. We can use our population mean. Our sampling distribution's standard deviation, though, is going to be slightly different. We're going to take the population standard deviation and divide by the square root of our sample size. Now, this is the calculation we really want to keep in mind as we get ready to go to our next exercises. Our standard deviation that we used in our z-scores before is going to change when we have a sample. It's going to change into the population standard deviation divided by the square root of the sample size. And we'll see some examples of that in the next video. Now, I could take these 10 means and plot them on a histogram. It wouldn't be very interesting and wouldn't really show us much of an interesting shape because we used an extremely small population and an extremely small sample of size 2. But if I have a normal-sized population, like the population of the United States being quite large, 350 million or so, and I take a sample that is larger than 30, this process would be huge, all right, but the resulting histogram would look like this. It would be a normally distributed histogram. So our sampling distribution of the mean is going to be normal if we have a sample size greater than 30. A sample size greater than 30 leads to a normal distribution in the sampling distribution, which means we can use the same z-score we've been using all along with the modification that our new standard deviation is the population standard deviation divided by the square root of n. And we'll see how to do that in the next video.